Stephen Hawking gave us some urgent advice. The astrophysicist who died in 2018 stated that the survival of mankind could only be ensured by moving to another celestial body. According to him, colonizing other planets would prevent our species from becoming extinct in the long run. The problem? With our current technical means, it's simply not possible for us to colonize an alien celestial body in a timely manner. Such an undertaking would take several centuries. Countless generations would be condemned to spend their lives aboard a spaceship. But fortunately, the status quo is not set in stone. Experts are already looking for new technologies to give space travel of the future an unprecedented boost in speed. And indeed, some scientists have already come up with breathtaking concepts in this regard. These include not only a propulsion system that does not require fuel, but also a technology that is supposed to enable us to travel faster than the speed of light. But what are the backgrounds of these groundbreaking ideas? How likely is it that they will one day become reality? Together with you, we want to take a closer look at this exciting topic today. Want to learn more about the exciting discoveries and unique spectacles in the universe on a regular basis? Then remember to subscribe to SimplySpace and click on the bell to stay up to date from now on. By giving us a thumbs up, you're motivating us and showing that we can keep you excitingly informed with the content of our videos. Cosmic moving hurdles. 6,300 years. That's how long it would take, with near-future technologies, to reach the closest exoplanet to Earth, Proxima Centauri b. So most people on board would never get to see either our blue home planet or the galactic destination. In a study, some experts concluded that at least 98 space travelers would be needed to bring a healthy crew to our distant neighbor. The researchers reached this conclusion by taking into account the age of the astronauts, potential infertility, the capacity of the spacecraft, and unforeseen disasters. However, it is uncertain to what extent the theoretical considerations of the experts can be transferred to reality. For instance, we do not know how the influence of space radiation and weightlessness will affect procreative capacity in the long run. In addition, it's possible that the newborn generations will have to deal with increased mutations as a result of radiation. But even if the men and women on board succeed in bringing enough settlers to Proxima Centauri b, a problem would remain. We currently don't even know if the exoplanet is truly habitable. The effort and the risks that such a mission would involve in the near future are therefore out of proportion. Basically, in order to travel in space, enormous amounts of fuel are needed. Naturally, however, the amount of fuel we can take into space is limited by the capacity of the spacecraft. In the absence of cosmic refueling stations, the challenge is to develop a safe and powerful propulsion system that uses as little fuel as possible. What initially sounds like a futuristic technology from a Hollywood flick has been discussed among experts for several years. An engine that can accelerate a spacecraft without fuel and produce no exhaust gases in the process. However, this groundbreaking idea is overshadowed by a major drawback. According to our current knowledge, it would violate the laws of physics. EMDRIVE. Conceived by Brighton Roger Shore, EMDRIVE is a hypothetical microwave drive. The revolutionary character of this new form of technology becomes clear to us when we compare it with classical engines. In simple terms, the current principle of action can be summarized as follows. As soon as something is ejected at the rear, a rocket moves forward. The effect underlying this phenomenon is called the interaction principle. Let's just think of an inflated balloon that is not tied. Thanks to the outflowing air, the object moves crisscross through space. The basic principle of EMDRIVE is based on the fact that thrust is generated without the need to eject anything. Or in other words, the spacecrafts of the future would no longer be dependent on classic fuel. But how could such a miracle drive actually work? The key to this groundbreaking concept is said to lie in microwaves. Generated by electricity in a closed copper cone, the movement of the microwaves would result in radiation pressure, which could be translated into directional motion. Although EMDRIVE is at odds with the law of conservation of momentum, It has been tested for its potential viability in several studies, and with the most surprising results imaginable. In November 2016, a NASA facility made headlines when it hinted at EMDRIVE's viability in a publication. Critics, however, consider it more likely that the proven thrust effect was due to unknown measurement errors or a faulty test setup. This is also suggested by the results published last year by staff at the Technical University of Dresden. The analyses of 3 EMDRIVE variations all painted a sobering picture. The thrust forces that had previously been determined were most likely caused by external factors and not by the actual drive. Warp drive. For science fiction fans, the spectacular warp drive is a familiar image. After the screen hero has operated a few levers and buttons, the spaceship chases through the cosmos at speeds faster than the speed of light. The question of whether such a technology could one day make it into reality is always the subject of heated debate among experts. A functioning warp drive would have to change the space-time area around a spaceship in such a way that the distance between the starting point and the destination is reduced. Thus, space-time would have to be compressed in the direction of the destination and expanded again after the passage of the spaceship. This manipulation of space-time with the help of gravitational waves would in turn have to take place at superluminal speed, which would enable the ship to fly along within this so-called warp bubble. What sounds spectacular and promising in theory faces insurmountable hurdles in reality. To bring such a technology to reality, a propellant with negative energy density would be required. However, such a form of exotic matter has not yet been observed. But even if we were one day to actually succeed in detecting particles with negative energy density, there would still be the problem that it would be needed in huge quantities. Eric Lentz, a researcher at the University of Göttingen, published a novel approach to faster-than-light phenomena last year. In detail, this means special distortions of space-time. These are so-called solitons, or in other words, standing waves that travel constantly, but without changing their shape. If we were able to travel within such a space-time distortion, it would be possible to circumvent a fundamental effect, time dilation. This exciting effect was first described in Einstein's theory of relativity. To illustrate the effects of time dilation, the example of a clock is often used. Clocks that move relative to the observer move more slowly than clocks that are at rest relative to the observer. Let us consider the twin paradox. In this thought experiment, one twin travels to a distant star at nearly the speed of light, while the other twin remains behind on our blue home planet. After traveling back to Earth at the same speed, the space traveler will find that he has aged less than his brother. But now, back to the revolutionary approach of Eric Lentz. Unlike the other warp drive theories, this exciting concept requires only already known positive energy densities. But does this theoretical availability mean that traveling at the speed of light can be put into practice in the foreseeable future? Unfortunately, some patience is still required in this regard, because also, in this case, the complication arises that the required amount of energy cannot be provided with our current means. The required energy corresponds to the 100-fold mass of Jupiter. Thus, it is necessary in the future to look for possibilities of energy saving. However, only the future can show whether this is really possible. Before that happens, it's worth taking a look at another exciting drive concept that is currently being discussed. Laser propulsion. SpaceX founder Elon Musk is known to be pursuing ambitious goals, the colonization of Mars. Anyone who dreams of settling on the red planet one day in the distant future should have staying power. With our current resources, a trip to Mars takes about 7 months. However, a new type of laser drive is now expected to drastically shorten this immense travel time, making it possible to reach our neighboring planet in just 45 days. The corresponding concept was presented a few months ago in the scientific journal Acta Astronautica. There, McGill University scientists describe how a giant Earth-bound laser would ignite the fuel of a spacecraft in Earth orbit. To do so, the moving laser would have to be 33 feet in diameter and reach a power of 100 megawatts. Then the oversized device would aim at a type of mirror attached to the outside of the spacecraft. This so-called laser thermal propulsion would focus and direct the incident laser light to ignite the hydrogen in the fuel chamber. In this way, a breathtaking cruising speed of 37,000 miles per hour would be achieved. Once the spacecraft was brought up to speed, the reflector could be undocked and brought back to Earth. Once there, it would be reusable, so that several spacecrafts could set off for the Red Planet at short intervals. However, this propulsion concept is accompanied by a problem that should not be underestimated. How does the spacecraft slow down on Mars? Since there is no corresponding laser there, the crew would have to complete a maneuver that is both demanding and energy sapping. The spacecraft would have to fly through the thin Martian atmosphere in such a way that it would be stopped sufficiently to be able to enter an orbit. It would then be possible for the astronauts to assume a stable position in orbit and initiate the landing approach. The forces acting on the people on board during the violent braking maneuver would be equivalent to 8 times the Earth's gravity. These are values that a person can just about withstand. As the planetary king of the solar system, Jupiter dwarfs all other planets. In theory, our Earth would fit more than 1,300 times inside the mighty gas giant. Moreover, the cosmic giant is almost 2.5 times heavier than all other members of our planetary system combined. For a long time, Jupiter embodied a galactic mystery for the experts. In the meantime, however, scientists have succeeded in uncovering some fundamental secrets of the celestial body, including the fact that Jupiter acts as a kind of terrestrial shield in the vastness of space, how the gas giant possibly saved us from total annihilation, and what questions still exist in this regard. You will learn in today's video. A colossus is born. That Jupiter is the largest planet in the solar system is well known. A few years ago, however, some scientists at the Westfälische Wilhelms-Universität Münster came to the conclusion that the gas giant is also the oldest member of our planetary system. Age determinations of various rock fragments of asteroids showed that the astronomical flying bodies formed about 1 to 4 million years after the birth of the solar system. During this epoch, however, there was no exchange of material between the regions from which the asteroid samples originated, a circumstance that can be explained by the fast formation of Jupiter. As soon as the cosmic colossus had reached about 20 Earth masses, after only 1 million years, it cut the material exchange between the two regions. These 20 Earth masses correspond thereby to the mass of the presumed Jupiter core. After the solid heart of the gas planet was formed, it grew by the accretion, or in other words, the accumulation of gas ever further. When it had cracked the 50 Earth mass mark, after only 4 million years, it went through another real growth spurt due to its steadily increasing gravitational pull, whereby the final mass of 384 Earth masses was reached extremely quickly. The very fast growth of the celestial body also had a direct influence on the formation of the 4 inner rock planets. As a result of its strong attraction, Jupiter directed water-rich asteroids from the outer regions of the solar system into the inner regions. Due to this, the theory stands that it was just these water-containing flying bodies which brought the cool liquid to our blue home planet. At the same time, rapidly growing Jupiter inhibited the growth of other celestial bodies. Thus, this circumstance prevented larger quantities of material from reaching into the interior of the solar system. This development might explain why we do not find any so-called super-Earths in our planet system, and why Mars remained relatively small. The Earth's protective shield. That Jupiter possibly once functioned as an indirect water donor of the Earth, we already told you. However, many experts also assume that the gas giant also acts as a kind of cosmic shield, which paved the way for the development of life on Earth in the first place. Just how devastating the impact of a gigantic asteroid turns out to be, the inhabitants of the Earth had to experience approximately 65 million years ago. At that time, a mass extinction of unimagined extent took place. 75% of all living beings, both animals and plants, fell victim to this dramatic development. It is considered very likely that this process was due to the consequences of an asteroid impact. In fact, the traces of this brute spectacle are still visible, Where the projectile from space once crashed to Earth, we now have the Chicxulub crater. Located in the north of Mexico's Yucatan Peninsula, this relic from prehistoric times is 112 miles in diameter. The experts found out that the impact body at that time must have had a diameter of 6 to 9 miles, so that it could unleash such a swath of destruction. From a purely statistical point of view, we must expect an asteroid impact of this magnitude every 100 million years. That our Earth moves only rarely into the path of dangerously large projectiles, we owe, according to the common doctrine, to a planetary protector, namely Jupiter. The background? With its enormous gravity, the gas giant functions like a kind of natural magnet, which bundles many comets and asteroids and keeps them away from our blue home planet. A quick look at the so-called asteroid belt shows how this influence is reflected in reality. Located between the planetary orbits of Mars and Jupiter, more than 650,000 astronomical small bodies cavort here. With a diameter of 597 miles, the dwarf planet Ceres is considered the largest known member of the asteroid belt. With its incomparable mass, Jupiter is a fundamental stabilizer of that area. If our galactic protector did not exist, our Earth would be hit by an object of the asteroid belt every 100,000 years. Purely statistically, the development of life would hardly be possible in view of a constant bombardment from the universe. Therefore, some experts believe that the presence of a Jupiter-like planet is one of the basic conditions for the development of life, and not only in our solar system, but also in all other constellations of the cosmos. However, we don't want to leave unmentioned at this point that this thesis is not free from criticism. On the contrary, some researchers see in the gas giant a real angel of death which set the decline of the dinosaurs in motion. Jupiter as a threat? A few years ago, experts conducted several computer simulations that resulted in extremely surprising results. Giant planets the size of Jupiter don't necessarily protect smaller celestial bodies from asteroids. In fact, they can increase the probability of impact. The experts came to this unexpected conclusion when they analyzed the so-called centaurs. These are asteroids and comets that move between the orbits of Jupiter and Neptune around the Sun. The researchers assume that these objects have their origin in the remote Kuiper belt. Under certain circumstances, it's possible that the centaurs could be deflected towards Earth. Within their computer model, the astronomers studied 10,000 centaur asteroids over a 10 million year period to find out to what extent Jupiter actually embodies the role of a terrestrial protector. Its mass was changed in 4 cases, with one simulation even dispensing with the mighty gas giant altogether. The amazing result? In the cases with and without Jupiter, the value of asteroids potentially dangerous to Earth remained unchanged. It's true that the Colossus deflects a part of the centaurs into the outer regions of the solar system. However, it also attracts a part of the asteroids into the inner areas and thus also into the direction of our terrestrial home. No less surprising were the simulation results in which the mass of Jupiter was reduced. In these cases, the planet even directed more asteroids inward than outward, which consequently also significantly increased the risk of an impact for Earth. Curse or blessing? To this day, scientific minds argue over what influence Jupiter really has on Earth's asteroid impacts. Sometimes, the objects in the asteroid belt collide with each other, which can ultimately put them on different, unstable orbits. If this is the case, Jupiter could act as a fatal amplifier. The gas giant's immense gravity would provide a decisive jolt to the errant craft, setting it on a deadly course towards Earth. The researchers who defend Jupiter as an earthly protector point out, however, that such assumptions are merely speculations, because in fact, we cannot say with absolute certainty where the near-Earth asteroids really come from. In the case of the cosmic projectile that sealed the decline of the dinosaurs, the experts suppose, however, that it originated from a collision in the asteroid belt. If one follows the remarks of the experts, then a brute spectacle preceded the terrestrial mass extinction. About 160 million years ago, an object with a diameter of 37 miles crashed into a larger asteroid with a diameter of 106 miles. When the projectile hit its counterpart at a speed of almost 7,000 miles per hour, numerous fragments were blown off. One of these fragments had a diameter between 6 and 9 miles and hit our Earth almost 100 million years later. It's well known that Jupiter has a dominant influence on the asteroids of the asteroid belt and can bring them to collision by its gravity. But does this mean, in the reverse conclusion, also that it was actually the force of the gas giant which steered the dinosaur killer on its deadly course? In view of the uncertain facts, this theory is not confirmed, because actually, the altered trajectory of the asteroid at that time cannot be explained with the consequences of the preceding collision alone. Mysterious birth of life. As we can see, Jupiter is mostly still considered as the galactic protector of Earth, but this was not always so, for in fact, the gas giant abandoned our terrestrial home for a time. Between 3.8 and 3.2 billion years ago, Jupiter and Saturn found themselves in a position where their gravity could no longer deflect enough asteroids away from Earth. As a result, the inner planets of the solar system faced an extreme bombardment from space. Particularly puzzling now appears the fact that many scientists date the emergence of terrestrial life to just that epoch. But how is this at all possible? In this respect, the researchers represent two opinions. Either the development of life was simply so probable that it could not be slowed down by the constant bombardment from space, or the other thesis is based on the fact that life would never have developed without the asteroid bombardment. Thus, the missiles brought some organic molecules to the Earth, which formed the foundation of terrestrial life in the end. If this should have really been the case, then Jupiter would have played a crucial role here, namely, by leaving our Earth abandoned at exactly the right time, only to reappear later as a steady protector. As is well known, no scientist, no matter how ingenious, has yet succeeded in developing a functioning time machine. However, this does not apply to the case of modern space research, because in fact, the James Webb Telescope should enable us in the near future to catch a direct glimpse into the primeval times of the cosmos. The recently published motifs impressively demonstrate the incomparable performance of the $10 billion device. In today's video, you'll find out which exciting formations and structures made up the pictorial prelude to the Webb mission, and which exciting areas the Space Telescope will turn to in the future. The dawn of the future. The future of modern space exploration has been quite a long time coming. After NASA, ESA, and CSA began designing the Hubble Space Telescope's scientific successor in 1996, a lot of patience was required. In fact, the development of the James Webb Telescope was not always blessed. For a short time, the US government even toyed with the idea of completely shelving the groundbreaking project. Fortunately, however, this unpleasant case was not to come to pass. Some 25 years and $10 billion later, Webb finally set off into the gigantic expanses of space on December 25, 2021. Less than a month later, it reached its intended target orbit, the so-called Lagrange point L2. From there, about 900,000 miles from Earth, Webb is expected to significantly expand our knowledge of the universe in the coming months and years. Why the launch of the telescope is often equated with the dawn of a new chapter in research becomes clear to us when we compare it with its predecessor. There is no question that we have Hubble to thank for many spectacular discoveries. The use of the explorer's floating eye has allowed countless exoplanets to be added to star charts. The iconic Hubble deep fields are still unforgotten, as are the groundbreaking insights Hubble gave us about distant supernovae and black holes at galaxy centers. Given the milestones achieved since Hubble's launch in 1990, it seems all the more impressive that Webb is up to 100 times more sensitive to electromagnetic waves than its predecessor. To vividly illustrate Webb's much-cited performance, NASA points to the following example. If the telescope were located on Earth, it could detect the heat of a bumblebee on the lunar surface from there. In detail, this technical masterpiece was designed specifically for infrared astronomy. This means that Webb can work from the red part of visible light to the mid-infrared spectrum. Instruments and tasks. To ensure that the telescope's instruments function smoothly at all times, they must be constantly cooled down. In addition to the selected target orbit, this is accomplished primarily by the powerful solar shield. On the side of the equipment facing away from the sun, therefore, frosty -387 degrees Fahrenheit prevails. The technical heart of the telescope, however, is the gigantic main mirror. Consisting of 18 hexagonal segments, it has a diameter of 21 feet. The main and secondary mirrors are coated with an extremely thin layer of gold, which also reflects very well in the infrared range. During its mission, Webb will have access to the most modern instruments of our time. These include the NIRCam, which will capture light from the earliest stars and galaxies, as well as the NIRSpec and FGS, nearest spectrographs. In international reporting, one of the 4 main scientific tasks in particular repeatedly makes the headlines: the search for the first luminous objects that emerged after the birth of the cosmos and during the so-called Dark Ages. However, this gripping look into the past by no means embodies the only field of research that Webb will devote himself to in the near future. In addition, new insights into the structure-forming processes in the universe will be gained. The telescope will also be used to study the evolution of galaxies, black holes, stars, and above all, protoplanetary disks, and to understand them better than ever before. Of course, one of the most fundamental questions in human history will not be left out. Are we alone in the universe? To get closer to the answer to this age-old question, Webb will look at exoplanets and check them for their potential habitability. Before the equipment will provide us with the first scientific results, however, a little patience is required because, as we know, the research mission is just getting off the ground. The breathtaking first Webb images, which NASA published a few weeks ago, therefore, give us a kind of foretaste of all the astronomical milestones that will be reached in the foreseeable future. SMACS 0723. How to meet the high expectations of the international public, which has been waiting for months for the first spectacular images from the Webb telescope. Not wanting to put its foot in its mouth, NASA gathered a team of experienced PR professionals. With the help of the consultants, the experts finally selected 4 images and a spectrum that would visually underscore the technical capabilities of our new eye in space. The original plans of the responsible persons were to unveil the corresponding images on July 12, 2022. However, US President Joe Biden did not miss the opportunity to present one of the motifs one day early, the fascinating galaxy cluster SMACS 0723. In detail, this collection of countless galaxies is located about 4.6 billion light-years away from Earth. That Webb's first deep field is bursting with detail is unmistakable. Among the thousands of galaxies are some of the faintest objects ever observed in the infrared range. Some of them appeared invisible to the terrestrial eye until this Webb image. Given the myriad of radiant entities sparkling towards us in the image, one might think that the photo covers a gigantic area of the sky, but the exact opposite is true. In the overall cosmic context, this section is no larger than a grain of sand viewed at a distance of an arm's length. CARINA Nebula. What at first glance looks like gigantic mountains and valleys, in reality embodies the edge of an important star-forming region. Dotted with countless twinkling stars, the highest peaks of this stellar cradle rise some 7 light-years into the sky. In all, the structure stretches 200 to 300 light-years. In fact, the CARINA Nebula, which lies in the Sagittarius arm of the Milky Way, has also been targeted by Hubble. However, due to its technical limitations, Webb's predecessor was unable to peer into the inner reaches of this stunning structure. The infrared images provided by Webb thus reveal some areas that previously completely eluded our view. Stephen's Quintet. It's a Wonderful Life is still one of the most popular Christmas classics of our time. But did you know that the angelic figures presented to us at the beginning of the movie are based on a real cosmic compound? Specifically, it's a group of 5 galaxies in the constellation Pegasus, commonly known as Stephen's Quintet. First added to the star charts in 1877, Webb reveals to us an entirely new view of this galactic assemblage. As a result, this stunning image is composed of more than 150 million pixels and consists of nearly 1,000 individual image files. The information Webb gathers will help us see how galactic interactions may have fueled the evolutions of the first galaxies. Indeed, the conditions prevailing in Stephan's quintet can be described in no uncertain terms as turbulent. As a result of their interacting gravity, the galaxies steal each other's stars, and even the giant tails of gas and dust keep changing galactic homes. Particularly surprising was the fact that Webb was able to detect a huge shockwave sweeping through large parts of the region. The small galaxy NGC 7318b could be identified as the cause of this brute spectacle. This galaxy plunges with a speed of a few million miles per hour in the direction of the group center, heating up the surrounding gases to several million degrees Fahrenheit. Southern Ring Nebula. Some celestial bodies undergo a spectacular end. When an old star reaches the end of its natural evolution, it begins to eject its home gas and plasma stores. The fascinating objects born in this way are called planetary nebulae, even though they have nothing at all to do with planets. NGC 3132, informally called the Southern Ring Nebula, also belongs to this group of astronomical objects. About 2,000 light-years away from our Sun, this object has a diameter of half a light-year. However, the Southern Ring Nebula has not yet reached its end. With every second that passes, it spreads out 9 more miles. The image provided by Webb allows us to peer more closely than ever into the interior of this stunning object. In particular, the white dwarf that once set the colorful spectacle in motion is clearly visible in the mid-infrared image. WASP 96b. A spectrum with symbolic character, the data collected by James Webb regarding the exoplanet WASP 96b show which milestones will be reached in this exciting field in the future. Accordingly, the instrument succeeded in demonstrating that the gas giant, 1,120 light-years away, harbors water and probably haze-like cloud structures. Spectroscopic analysis is essential to study a planet in terms of its habitability. This reveals the existence of specific gas molecules in the form of tiny variations in brightness, enabling experts to make fundamental statements about the atmospheric composition of an exoplanet. Now it's time for your opinion. Which Webb image fascinated you the most with its subject? As always, drop us your thoughts, suggestions, and feedback on today's video in the comments below. Are you in the mood for more exciting contributions on the topic of outer space? Then take a look at the other videos on our channel, which you can access by clicking on one of the images in the credits. Thanks for your interest. Take care, and we'll see you next time.